Among the following, the correct statement is. The options are shown here. Here we have to select the correct statement of isolability. Two fragments or molecules are said to be isolable if their frontier orbitals are in same number, same symmetry, same occupation by electrons, similar in radial extent. Isolability is indicated by double-headed arrow with a teardrop in the middle. Actually, isolability can be determined by in crude way, that is by number of valence electrons of fragment and electron short of filled shells for CHN and MLN. First, we calculate number of valence electrons of fragment for CH and tricarbonyl cobalt. Here cobalt is the D7 configuration. The number of valence electrons for CH are 5. Here it requires 3 electrons to get the stable configuration. Number of valence electrons for tricarbonyl cobalts are 15. Here also it requires 3 electrons to get the stable configuration. Next we calculate for CH2 and dicarbonyl nickel. Here nickel is the D8 configuration. The total number of valence electrons for CH2 are 6. It requires 2 electrons to get the octet configuration. For dicarbonyl nickel, the total number of valence electrons are 14. It requires 4 electrons to get the stable configuration. Next, we calculate for CH and tetracarbonyl ion. Here ion is the D6 configuration. The total valence electrons are 5 for CH. It requires 3 electrons to get the octet configuration. Here tetracarbonyl ion has 16 valence electrons. It requires 2 electrons to get the stable configuration. Next we calculate for CH2 and tetracarbonyl manganese. Here manganese has D5 configuration. The total valence electrons are 6 for CH2. It requires 2 electrons to get the stable configuration. Valence electrons for tetracarbonyl manganese are 15. Here it requires 3 electrons to get the octet configuration. Now we have the electrons short of filled shells for all the fragments. Now we check the isolability for each pair. For the fourth pair, the number of electron short filled shells are not same. For CH2 it is 2, for tetracarbonyl manganese it is 3. So it is not isolable. Second, we check for CH and tetracarbonyl ion. Here also the number of electron short of filled shells are not same. So this is also not isolable. Next we check for CH2 and dicarbonyl nickel. Here also the number of short of filled shells are not same. This is also not isolable. Next we check for CH and tricarbonyl cobalt. Here the number of electrons short of filled shells are same. In both the cases it has 3, so it is the correct isolable pair. So the correct statement is CH is isolable to tricarbonyl cobalt. Thank you.